All right, we're going to learn how to solve nonlinear inequalities. And to get us started, I'm going to solve a linear inequality just so we know what we're talking about. So I've got 4x plus 8 is less than 0. And so I subtract 8 from both sides. I divide by 4, and I get x is equal to, or x is less than negative 2. So if I wanted to show that solution on a number line, well, I would have an open circle at negative 2, and x would be everything less than negative 2. And in interval notation, we would say that x can go from negative infinity all the way up to but not including negative 2. So that's how you solve a linear inequality. Nonlinear inequalities are a little bit trickier. What you need to do is make sure they're completely factored before you try and figure out their solution. So here we go. If y'all notice, I can take the first two terms and group them together. And I can group the last two terms. So I'll do a negative x plus 3. And then I can take an x squared out of this, leave me with x minus 3. And I can take a negative 1 out of that, leave me with x minus 3. And that's still greater than 0. Now, do you see that from this term and that term, I can factor an x minus 3 out? And so when I do that, I'm left with x squared minus 1. And that's greater than 0. We're not completely factored yet. One more step. There we go. Okay, so what does this mean? Well, on the number line, I've got x will make the whole thing 0 at negative 1. Put an open circle there. At positive 1 and at 3. And what we're going to do is we're going to test points that are in each of these regions. I have 1, 2, 3, 4 regions to test. So let's pick a number, any number to the left of negative 1, say negative 2. Now if I put negative 2 into this factor, that factor will be negative. Negative 2 minus 1 is negative, and negative 2 plus 1 is still negative. So when I multiply three negatives together, I get a negative result. So any number to the left of negative 1 will make this whole expression negative. Now pick a number between negative 1 and 1. Okay, how about 0? 0 minus 3 is negative. 0 minus 1 is negative. And 0 plus 1 is positive. A negative times a negative times a positive is positive. Pick a point between 1 and 3. Say 2. 2 minus 3 is negative. 2 minus 1 is positive. And 2 plus 1 is positive. Negative times positive makes negative. And then finally, if I pick a number greater than 3, I'll get positive, positive, positive all the way across, which of course is positive. Now we originally wanted all values of x that make this whole thing more than 0. In other words, we want the values of x that make it positive. So that will be right here and right there. In interval notation, we would say that x can go from negative 1 to 1 in union with 3 to infinity. So let me show you how the graph of the function is connected to this inequality. So here's the graph of that polynomial we just looked at. And remember that we wanted to know where was it greater than 0. So all you need to do is to check out where the function itself is above the x-axis. So here's the graph of the function, and you can see that it's above the x-axis from, it looks like, negative 1 to 1, and it's above the x-axis from 3 on out. Okay? So you can use the graph of a function to solve an inequality as well, and we'll do one in a little bit on our graphing calculator. You can also do inequalities that have rational expressions. But what you want to do is make sure that it's one fraction totally factored out. Okay, so what I did was I got a common denominator of x plus 1. Now, I got x plus 6 minus 2x minus 2 all over x plus 1 less than 0, which means that I have 6 minus 2, which is 4, and x minus 2x, which is negative x, over x plus 1 is less than 0. All right, so on our number line, first of all, if x is 4, it will equal 0. So I'll put an open circle there because I don't want it to equal 0. I want it to be less than 0. And also, if x is negative 1, the whole thing is undefined. So I have to avoid that spot too. So I'll put an open circle there. Okay, let's pick a number to the left of negative 1, say negative 2. So 4 minus negative 2 is positive 6, and negative 2 plus 1 is negative. A positive divided by a negative is negative. Okay, pick a number between negative 1 and 4, like 0. 4 minus 0 is positive, and 0 plus 1 is positive. So that will be positive. And finally, pick a number greater than 4, like 5. That'll be negative. 4 minus 5 is negative 1, and 5 plus 1 is positive. Negative divided by positive is negative. So remember that we want this original expression to be less than 0. So I'm going to highlight all the places where the whole thing is negative. And in interval notation, that means we're going to go from negative infinity to negative 1 and 4 to positive infinity. So you can also use your graphing calculator to solve inequalities. And I've loaded this into my y equals. So I'll drag it over there. And I'll hit zoom 6. And there's the graph of the function. And we are interested in all the places where this expression is less than or equal to 0. Less than or equal to. That means where it is below the x-axis. Okay, so I'm going to go to second calc. I'm going to select 0. I'm going to get that x-intercept right there because here it's above the x-axis. It's greater than or equal to 0. We don't want that. And it's greater than 0 there. We want it less than 0 where it's below the x-axis. So I'll pick 0 as my left bound, and I'll pick, say, 5 as my right bound. And hit enter, and there we go. So what is this graph telling us? It's saying that between negative 1, where this vertical asymptote is, there's a vertical asymptote at negative 1. And how do I know that? Because of that x plus 1. If x was negative 1, it'd be undefined. So there's a vertical asymptote at negative 1. So between negative 1 and 2, it is less than or equal to 0. So in interval notation, that would be parentheses negative 1, comma, 2, bracket. And I use the bracket because it can equal 0. All right, so what good is this stuff for? Well, it lets us find domains of functions. And so here we have a function that is a radical, the square root of x squared minus 2x minus 15. And if I'm taking the square root of something, I can only take the square root of things that are greater than or equal to 0. So I'm going to take everything underneath the square root, and I'm going to force it to be greater than or equal to 0. So we factor it, and I believe it's going to be x minus 5, x plus 3. And on the number line, that means it's equal to 0 at negative 3 and at 5. Let's pick a number to the left of negative 3, like negative 4. Negative 4 minus 5 is negative, and negative 4 plus 3 is negative. So that's positive. Pick a number between negative 3 and 5, like 0. 0 minus 5 is negative, and 0 plus 3 is positive. Negative times positive is negative. And finally, pick a number more than 5, like 6. That'll be positive and positive, which makes the whole thing positive. Well, since I can only take the square root of things that are positive, greater than or equal to 0, that means that my domain is going to be less than negative 3 and greater than 5. So that's what we say. Negative infinity to negative 3 and 5 to infinity.